This is for MAT 1033, Chapter 4, Section 2, Systems of Equations. This deals with systems of three equations. As you can see right here, I've got equation 1, which is 3x minus y plus z equals negative 5. Equation 2, which is x plus 2y minus z equals 1. Equation 3, 2x plus 3y minus 2z equals 0. Notice that in a system of three equations, we have to have three variables. Now, not necessarily three variables in each equation, but there must be three variables that we solve for. In other words, we solve for what we call an ordered triplo. All right. So what happens here is I got to find the easiest way to bring this system of three equations down to a system of two equations. So what I want to do is I want to combine two of the three equations in two separate additions to get two equations that are with the same two variables. So what I chose in the first one was and it doesn't matter whether you solve for x, y, or z, because you're going to end up solving for all three anyway. So there's multiple ways to do these problems. I'm just showing you one way. I chose equation 1 and 2 because as you can see, if I just add them straight up, I have a positive z and a negative z, which they're going to cancel out. So what's going to happen is when I add these two equations, I get 3x plus x, which is 4x. I get 2y minus y, which gives me y. And then over here, I get negative 15 plus 1, which gives me negative 14. So there, I want to now add two different equations from the three to get a second equation with x and y. I chose equation 1 and equation 3. And what I did with equation 1 was I multiplied it by 2. By multiplying by 2, it gives me a positive 2z, which when I add to equation 3 with a negative 2z, they cancel out. And so by multiplying by 2, I get 6x minus 2y plus 2z equals negative 30. When I add the adjustment of equation 1 to equation 3, I get 8x plus y equals negative 30. And I should have an equal sign. 8x plus y equals negative 30. So now I have 8x plus y equals negative 30. I have 4x plus y equals negative 14. If I bring them over here, I'm now going to solve these two equations. And we'll get rid of the y's. We'll get rid of the y's by multiplying 4x plus y equals negative 14 by a negative 1, which makes it a negative 4x minus y equals a positive 14. When I add these two equations together, I get 4x equals negative 16. Divide by 4, I get x equals negative 4. So what I'm going to do with the negative 4 is I'm now going to take that and substitute it back in to one of these two equations here. I have to substitute it back into an original, not one that's changed. I chose the top equation. So what I did was I took the negative 4, put it in for x, and now I have 4 times negative 4 plus y equals negative 14. I get negative 16 plus y equals negative 4. Add the 16 over, I get y equals 2. Now what I have to do is I have to take this 2 for y and this negative 4 for x, and substitute it into one of the original equations. I chose equation 2. So here's equation 2 here. And remember, I have to substitute it into an original equation. So I substitute the negative 4 in for x, the 2 in for y. Gives me negative 4 plus 4 minus z equals 1. I get negative z equals 1. Multiply by a negative across, and I get z equals negative 1. And thus I have my ordered triple, which is negative 4 for x, 2 for y, negative 1 for z. Again, let me say this. In a system of three equations, it does not matter if you solve for x first, or y first, or z first. Doesn't matter. There's multiple ways to do these problems. You just want to combine two equations on two separate occasions to get rid of the same variable, so you have a system of two equations in the same two variables. Then you just solve that like we did all the problems in section 1.